Hello and welcome to week 4. We're going to talk about factoring this week, and the whole week is devoted to factoring. So I do need to caution you, if there's anything from week 3 that is still confusing, you do need to go back and get really sure yourself with all of that, because we're doing what we did in week 3 except in reverse. So last week we were multiplying for the most part. This week we are factoring, and you're going to use multiplication to check. So it's really important that you understand week 3 really well. All right, so factoring is just breaking up something into its factors, which makes sense. So this is an example of breaking up 24x to the third into factors, and notice how there's a lot of answers. That will not be the case for what you do. This is just showing you, what factors are, but you're going to see something more like this. If you look at the bottom left, you see where we have 4x times x to the second plus 3x minus 4. Now, we already learned how to do that last week. We just multiplied 4x through by everything. If there were like terms, we combined them. What we're going to do now is the reverse. We're going to start with our answer, what would have been our answer last week, and we're going to factor it. So the first thing I want to look for always, and this is so important, you should write this down, the first step is always to see, is there a common factor? Right? If there's a common factor, you need to factor it out. So the greatest common factor of 4x to the third, 12x to the second, and 16x is 4x, because 4 is the largest thing that goes into 4, 12, and 16, and x is the largest thing that goes into x third, x to the second, x to the first. In other words, I think you can probably feel okay about 4, 12, and 16, that 4 is the greatest common factor. X might be a little bit harder, so just think about it this way. Think of what's the largest number of x's I can pull out without going over. Okay, I can't say x squared is a greatest common factor because I only have one of them in that last term. So it's the biggest thing you can pull out for all of the terms. And here's what I do. When I determine my greatest common factor, I divide each term by that greatest common factor. So 4x to the third over 4x is x to the second. 12x squared over 4x is 3x, and negative 16x divided by 4x is negative 4. And what I'm circling here, that is our final answer. Don't forget the greatest common factor that you pulled out. That's always got to be included. All right, let's factor this one. What's the greatest common factor of 9 and 21? 3. I can't pull out a variable because I don't have not even one a common to all terms, so I can pull out a 3 and that's all. So remember what I said to do just a second ago. We're going to divide each term by that greatest common factor, which is 3. Okay, and this should look familiar from last week. And what am I left with? 9a over 3 is 3a. Negative 21 over 3 is negative 7. And what I'm highlighting here, the whole thing, that is our final answer. The great thing about this is to check, all we have to do is multiply back. Okay, this example is similar. The greatest common factor is 3x to the third. That's the largest thing I can pull out of all of those terms. And don't be afraid to actually do this. Go ahead and actually show this division and divide each of these terms. I won't write it in all 3 cases, but that's what you're writing under each of these. 3x to the third. That's what you're writing. And then you're just doing the division, and look what we're left with. And again, to check, we can use the distributive property. All right, so this is another example. There's a ton of examples in this set of slides, so I'll never be able to get through everything and keep it a reasonable amount of time for a video for you. So I'm going to skip a lot of examples. Please download the PowerPoint presentation and look at them. They're really going to be very helpful. So remember, the most important thing is to look for the greatest common factor, if there is one. 1 is always a common factor, but we're not talking about that. If there's not a common factor, you can move on and look at the next step. So there will be something you can do if there is no greatest common factor, so I don't want you to be afraid of that. But looking for the greatest common factor is always the first thing to look for. Also, we can always check our answers for factoring by multiplying. I must caution you that it is possible to factor without factoring out the greatest common factor and still getting a right answer, but your answer would not be correct. So I don't want you to get a false sense of security. Multiplying does check, but if you forgot to pull out the greatest common factor, you will think you're right, but you're not. So that's why it's so very important that you always look for greatest common factor. All right, factoring by grouping sounds terrible, but it's not. If you look at it, I've got two terms here. Here's a term, and here's a term, right? Aren't terms separated by addition and subtraction? I've got two terms, and I want to know if you see something common to both terms. Hopefully you do. Hopefully you see that x plus 2. That's common to both terms, so that is my greatest common factor. And what am I left with? Well, remember, I divide by that greatest common factor and cancel, and I'm left with x squared plus 3. This is my final answer. So usually you can use grouping for trinomials, but I don't typically do that unless I'm told I have to. I like to factor by grouping for when I have 4 terms. As a matter of fact, when you see 4 terms like you see here, that is the method you want to do. You want to try. But always look to see if there's a common factor. So if I look at example A, before I start thinking grouping thoughts, which is starting to seep into my brain, I look at that and I think, what's common to all 4 of those terms? And there's nothing. So then I move on to my next step that I mentioned before. You know, if there's no greatest common factor, go on to your next step. It might be there's nothing you can do whatsoever. And I do caution you that you only want to call something prime if you can't factor it at all. If you can factor out a greatest common factor and that's all, it's not prime. You were able to factor something. It's only when you can do nothing that it's prime. Anyway, for example A, I'm going to put things in groups, and I color-coded it. So you see I put the first 2 terms together and the second 2 terms together, and I colored them. So I've got orange and blue. So the first 2 terms I'm going to treat like a whole separate problem. And I'm going to factor out a greatest common factor looking at just those 2 terms for a minute. I have 3x squared, and I'm left with x plus 3. When I'm doing grouping and I'm thinking ahead a little bit, I know I need to have something that I factor out for that second set, that x plus 3. So I'm going to factor out a 1 because I know it won't change anything. When I'm done, I can see that I have a common factor of x plus 3. That's what has to happen. If you don't have that, you need to check and see if there's a mistake or try a different grouping or something. X plus 3 is my common factor, so that's what I pull out, and what I'm left with is what I get when I divide each term by x plus 3, and that leaves me with 3x squared plus that 1 that seemed insignificant, but now you see it really is important. So what I just circled is the full answer. More examples. All right, I'm going to go right to here. I'm going to show you what I do when I factor something like this. I am going to show you a lot of examples, or at least give you access to a lot of examples, but I'm not necessarily going to walk you through them all, but just ask me if you get stuck. So if I look at this one, I'm going to think FOIL backwards. I'm going to first place my first and then my last and see if inside-outside works out, or outside-inside, same thing. All right. So the thing to remember with factoring is kind of like long division last week. It involves some trial and error, and I don't want you to think anything's wrong if there is some trial and error. So there will be some trial and error. You will guess wrong. I know I did, probably still do. You know, that's okay. That's just part of factoring. So you're going to draw your 2 sets. First of all, do I have a greatest common factor? And in this case, I don't. So now I'm going to try reverse FOIL. So what times what is x squared? I'm going to try x and x. That takes care of this term. Now think last. What times what is 12? I kind of see the answer below, but you can see all those possibilities in that chart. So 4 and 3. Okay? 4 times 3 is 12. So I know F and L in FOIL works out. What I have to do is see if outside inside works out. I need a positive 12, so these both have to be negative or both positive. If I have them both negative, I'm going to get a negative middle term, which I don't want. So I'm going to make them both positive. And then I'm going to do FOIL, I know first and last are right, so I actually could skip that in my check and just do outside inside. I get 4x plus 3x, which is 7x. That's exactly what I wanted. I got it. That's it. So you'd find if you tried like 6 and 2, you'd get a middle term of 8x. That would not be what you wanted. So you would just erase and try it again. Okay, so scratch paper is going to be very important. And this is another example. So I've got a lot of examples. I don't want you to memorize formulas. If you want to, that's fine. They're in this presentation and they're in the book, but I think they're confusing. I think it's easier if you just try FOIL backwards. Okay, so like this one, first and first, last and last. Okay, I've got to get a negative 24, so one's got to be positive and one's got to be negative. You know, I could see me trying 4 and 6 first. All right, and if I did, I would have gotten a wrong middle term, so I would just try it again. All right, but positive 3 and negative 8 will work, and checking outside inside gives me a middle term of negative 5x, and I am indeed correct. Now, this example shows the importance of order. Notice how I have the t squared and then negative 32 and plus 4t, and I don't want that. I need to write it as t squared plus 4t minus 32. Once you do that, you know, again, is there a greatest common factor? No, but I can put my first, my last, inside, outside, see if it works out. So we have lots of combinations, and you will be trying different combinations, but when you hit one that works, that means, you know, you got it. Even if you have more than one variable, no problem. Okay, here's a great example for that. So I'm going to leave you with this thought before I go to the next video, but you can only have a prime polynomial if it cannot be factored at all. All right? So if there is a greatest common factor and that's all you can do, that's not prime. A lot of people on the quiz, I notice sometimes they just click prime, 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 prime for all the answers, hoping a couple of them are prime. Please don't do that. A lot of them have show work components. You need to justify an answer of prime. All right, so don't just click it. Make sure you know why. But it's only if nothing else can be done. Also, you always want to make sure that you factor completely. I'll talk about that in the next video, but you want to make sure that once you factor, see if you can factor even more. All right, so join me for the next video, please.